Today we're going to talk about probability, and I'm going to introduce contingency tables. Let's say we have a group of individuals, 400 altogether. Some of them are male, some are female, and some like a car because of its appearance, and some would buy a car because of its performance. The totals that we are given are 180 like a car because of its appearance, 220 like a car because of its performance. The number of men in our group is 250, and we have 150 females in our group. So we're going to use these abbreviation M and F to represent the event that somebody is a man or a woman. And we're going to use these abbreviations A and P to represent the events that somebody buys a car because of its appearance or because of its performance. There are three types of probabilities that you can compute. First, there are marginal or simple probabilities. Marginal, or another way of calling it is simple probabilities. This is the probability of a single event. For example, we could write probability of being a male is equal to, and since we have 250 altogether out of 400 individuals, we put 250 out of 400, which gives us 0.625, or the probability of being a female is 150 out of 400, which gives us 0.375. Notice that these two probabilities add up to 1, because there are two ways that you can there are two events that describe the gender of a person, either male or female. So collectively, they both must add up to 1. We can write these probabilities in a different shade. I'll use red, and the probabilities therefore are 0.625 and 0.375, and they add up to 1. So the numbers in black are frequency counts, and the numbers in red are probability values. We can do the same thing, and we can compute probability of the other two events that we have in this study. Probability of somebody buying a car because of its appearance is the total, which is 180, over the overall total, which is 400, and that would be 0.45. And probability of buying a car because of its performance is the summation 220 over 400, which is 0.55. Of course, I didn't need to even calculate this. I know that if I take 1 minus 0.45, that should give me the complement. Your book talks about complement events that are complementary to each other, and that's what A and P are to each other, and that's what M and F are to each other. So I can write the probability values here also, 0.45 and 0.55. Notice that both the column totals and the row totals add up to 1. So those are marginal or simple probabilities. Let's talk about joint probabilities. Joint probability is the probability that two events occur concurrently or simultaneously. So we have the probability of M and A. The symbol to use for AND is this upside down or inverted U, and it represents the intersection of two events. So we say probability of M intersect A equals, or another way of saying it is probability of M and A equals. And in order to compute that, you need to go to the intersection of those two events, which in this table would be 120, and you want to know what that is relative to the overall total, which is 400. So when you do that, you're going to get 0.3. So I can write that joint probability value in that cell, so that we're converting this frequency table to a joint and simple probability table. We have another joint probability, probability of F and A would be the 60, which is at the intersection of these two events, divided by 400. And that number would be 0.15. We can also compute probability of M and P, which would be 130 divided by 400, and the answer would be 0.325. And the probability of F and P, which would be 90 divided by 400, and that would give us 0.225. Notice that all of these joint probabilities add up to 1. I'm going to write those in here. 0.15, 0.325, and 0.225. Here are some things that you should observe. These two joint probabilities add up to the probability of being a man. So there are two, essentially you can say that there are two ways that you could be a man, describe a man in this sample. You could be a man who likes a car because of its appearance, or you could be a man who likes a car because of its performance. Combined, the probability of both of those subsections equals the probability of being a male. Same thing here, and also same thing this way. There are two ways, or there are two groups who buy a car because of its appearance: the men and the women. The joint probability of both equals to the simple probability of appearance. The same relationship holds here. I want you to also look at one more thing. Probability of M and A equals probability of A and M, because the intersection of M and A, or A and M, is the same group, same 120 individuals. So either way, the probability would be 0.3. You could make the same conclusion concerning all of these. This would be probability of A and F. This would be probability of P and M. And this one would be probability of P and S. So the point to be made is that when you're working with an intersect and with the AND probability, where the location of the event, where to put it inside the parentheses, it doesn't make a difference and it doesn't change the value. And finally, we want to talk about conditional probabilities. Conditional probabilities also have two events written inside of the parentheses, but the order does matter. Let's talk about probability of being a male given that you buy a car because of its appearance. Probability that you are male given that you buy a car because of its appearance is different from probability of buying a car because of its appearance given that you are a male. This is a straight line, it's not a slash, and it is to be read given. So probability of being a male given that you buy a car because of its appearance. So the given event comes after this symbol. Now, this one is probability of being a male given that you buy a car because of its appearance. We know that people who buy a car because of its appearance, there's 180 of them. So we're zooming in to the appearance folks. There's 180 of them. Now we want to know, out of those people only, not the entire 400, but only out of those 180 who buy a car, given that they buy a car because of its appearance, what is the probability that somebody is a male? So I'm looking into this column only, and the men that fit in there is 120. So 120 divided by 180 is what the answer is. M given A, I don't have that yet computed, but that's what that would be. And similarly, here, probability of buying a car because of its appearance, given that you're a male, now we're looking at the male group, so that's 250. Out of those, we want to know how many of them buy a car because of its appearance. Well, that's the same 120. So the numerator happens to be the same in these two calculations, but the denominator is different because the given event is different. And in this case, sorry about not being prepared. We have 120 divided by 120 divided by 180. This is 0.667, and this one is 120 divided by 250, so this is 0.48. Now, given that you are a male and you buy a car because of its appearance versus probability of being a female and buying a car because of its appearance. The females are 150 of them. Buying a car because of its appearance, there's 60 that do that among the females. So 60 divided by 150 gives you 60 divided by 150 is 0.4. So given that you're a male and you buy a car because of its appearance, you have a 48% probability of that, a 48% chance or 0.48 probability of that, versus a 40% chance or 0.4 probability that you would do that if you're a female. So that's how you can compare the two analysis. Similarly, you can calculate probability of MA, AM, AF, FA, F given A, probability, and other probabilities. Anyways, performance, M given P, probability of P given M, probability of F given P, and probability of P given F. Each of these can be computed. Now notice that probability that given that you're a man, given that you like appearance, for example, what's the probability that you're a male? That's 0.667. Notice that probability of F given A would be 60 over 180, which is 0.333. And notice that these two probabilities add up to 1. So essentially we're saying, given that you like a car because of its appearance, and we're looking at that group only, these two subgroups add up to that 180. The probability of males who buy a car because of its appearance and the probability of females who buy a car because of its appearance. So 0.667 and 0.33 add up to 1. So we have probability of M given A plus probability of F given A equaling 1. And that's the relationship that you will find as you do further analysis with the rest of them. Thank you.